Good evening, Mr. Trevor. My name is Vijay Sivanathan, and I'm here to basically talk about the benefits of using R over SPSS. I've heard that you wanted to use SPSS to carry out statistical analysis on data sets. I'm here. I want to give you information about using that SPSS is not as good as using R. R have many more features that are more better than SPSS. So basically this presentation is basically here I'm basically going to present to you the benefits of using R over SPSS. So the first benefit of using R over SPSS is R is free and is an open source. Whereas SPSS you have to pay more money to install that software. Whereas for R, since it is free, it doesn't burn a hole in your pocket, and it's also an open source. So you basically you don't lose any money, and you basically can use the software for free. That's the first benefit of using R over SPSS. The second benefit of using R over SPSS is you can ask the global online community for help anytime. Whereas for SPSS, you can't ask any online people to help you, but you have to do own research on that particular topic and figure it out your own self. For example, in my experiences of using R, I used to struggle to use R to code things on R during the first few tutorial sessions in class. However, I've got a lot of I received many help from the global online community, which are my friends, that helped me overcome my problem and basically solve the issue that I'm struggling, which is the things that I don't understand in R. Also, I'm basically gaining more knowledge by asking more people about R, and now I'm getting a hand of using R. So that's one of the best reasons of using R over SPSS. The next reason of using R over SPSS is every error that you make on R is Googleable, and you don't need a teacher to explain on why you got the things wrong. So basically adding on, if example your friends don't know the answer to your problem, you can basically Google the correct code, and basically find out your own information on yourself on the things that you don't understand, and your friends that even when your friends don't understand too. So basically by using the software R, we're able to find all the information on Google, and we can self-study it and become better in R every single day. Whereas for SPSS, the things that are needed to be coded down are really hard to be Googled on the internet. So we need a teacher to explain all the information that we need to code about SPSS. Whereas for R, we can do our own self-study and etc. The next benefit of using R over SPSS R is a more evolving and becoming a more stable / powerful every day, becoming more stable and powerful every day with new packages that are created for analysis in different fields. So for example, SPSS, they only limited to few fields, whereas for R, R is basically widespread to many fields, such as ecologists, doing any conservation science, and even for biomedicine too. You can use R to basically transfer all the information from your research. So that's the first 4 reasons of using R over SPSS. Now I'll move on to the next slide to explain the other 4 reasons of using SPSS too. You can produce much more publication worthy graphics by using R over SPSS. SPSS is basically a lesser publication worthy, has lesser quality of graphics, whereas for R has even more better quality for graphics. So by using R, we will be able to grab the attention of our buyers and make sure our research that we have published on the website will be more entertaining for the people to look at. The next benefit of using R over SPSS is R is becoming increasingly compulsory in journals to share their code and to ensure that the science is reproducible, whereas for SPSS it is totally opposite, because for this generation, in this time of era, SPSS is not commonly used when compared to R. So we need to live out to the social norm, and basically to be able to excel in life we have to use R compared to SPSS. Following this, if we use R, it is less likely that our paper will be rejected during the peer review stage, whereas for SPSS, it is most likely our proposal letter will get rejected, as this is not what the boss wants us to do. So this is the 7th reason why we should use R over SPSS. And the 8th and final reason of using R over SPSS is R is even more cooler, and it could help you get a job easier when compared to SPSS. Like I said in the previous point, R is even more easier to be getting accepted at the peer review stage. So when we get accepted, it is most likely we will get a job / a scholarship when compared to SPSS. When SPSS, basically the likeliness of getting a job is lesser, because the paper is being rejected during the peer review stage. So these are the few benefits of using R over SPSS, and now I'll explain the few tests that can be carried out on R. Stay tuned to the next part of the video. So in this part, I'll basically demonstrate to you how to install R on your computer. After that, I'll also demonstrate to you how to use the R script editor, and lastly I'll demonstrate to you how to export the randomly generated dataset in an Excel spreadsheet. So firstly, how to install R, you just have to go to Google here, and you just have to click it right here, install R Studios in Windows 10 if you're using Windows 10, or install R Studios in Mac if you're using Mac. So for me personally, I use Windows 10, so this is how I use to download R. I'll click this website here, and it'll bring me to this page. When I'm in this page, I'll just have to scroll down and click R Studio Desktop. There's a download button there. If you click it, you will basically download R. So this is the way. So this is how you have to install R, Mr. Trevor. So the next part is I'll basically explain to you how to use the R script editor. So in this part, I'll open the random dataset generator here, and basically before you highlight this whole thing, you have to do something. The thing that you have to do in line 59 is you have to put df gen 30. So after you put df gen 30, you put dataset lesser than arrow df gen 30 here. So from here you can just run all this thing. When you run it, you'll get these values here. However, to get our own data set, we'll just have to call it again. So by just clicking dataset, it will automatically come out. So this is our data set, my own data set, because Mr. Trevor, in our class, many people get different data sets. So this is how I use the R script editor to basically show you how to use the R script editor. So in this part, so I've completed the second part of the assignment. So now basically in the R script editor, so there's two parts. So basically this is the part where we code our information, and down is the console, is where the information comes out. So now the third part, which I will explain, is how to export the randomly generated dataset in an Excel spreadsheet. So for this part, we'll have to add few information. We have to put write.csv here. Click this thing. We have to put dataset, comma, hyphen, dataset dot csv. So after we did this thing and we run it, we'll get this thing, and now we just have to check our file. So when we check our file, basically it shows here the data set. So this is how we export the data set, the randomly generated data. This is the fourth part of my assignment, Mr. Trevor. So in this part, I'm basically going to explain the concepts of an ANOVA test and the differences between a one-way ANOVA and a two-way ANOVA. After that, I'll demonstrate to you on how to conduct a one-way ANOVA on the same dataset by using a research question that I've created. So firstly, I'll explain to you what's an ANOVA. An ANOVA is a statistical test that is used to separate observed variance data into different components to use for additional tests. An example of an ANOVA test is, can we find whether there's a significant difference in the mean weight loss among 4 diets? So this is an example of a research question on an ANOVA test. After that, following this, if the variance between the groups is more than the variance within the group, this will then show that there is a significant difference between the groups, because this is because the null hypothesis will be lesser than 0.05, so we will have to reject it, and this therefore shows that there is a significant difference between the groups. Whereas if the variance between the group is lesser than the variance within the group, this will then show that the null hypothesis will be accepted, and we will then describe that there is no significant difference between the groups. So after stating what is an ANOVA test, now I'll show you the differences between a one-way ANOVA and a two-way ANOVA. A one-way ANOVA is used to compare the means of usually more than 2 groups, and is also used when the data is organized into several groups based on a single grouping variable. Whereas a two-way ANOVA is used to compare the effects of 2 grouping variables on a single response variable. That is the difference between a one-way ANOVA and a two-way ANOVA. So after explaining to you what a one-way ANOVA and a two-way ANOVA is, I will now demonstrate to you on how to conduct a one-way ANOVA on R. So firstly, we'll have to create a research question. So my research question is there a significant difference on the ethnicity towards their monthly income? So that is my research question. After this, we will have to create subsets. Before doing the Shapiro's test. So the subsets are supposed to be written like this: group 1, arrow, subset, data set, comma, ethnicity, equal sign, Malay. Make sure the Malay is in small letter, because if based on the document that is given to me, the table, it is shown that it is in small letters, so we have to follow that. If it's in capital letters, we have to put in capital letters. So now I'll do it for the same thing for group 2, which is for Chinese. Just amend here, group 2, subset dataset ethnicity Chinese this time, so Malay, and now the last one for Indians. Group 3 subset dataset ethnicity, now from Malay we change it to Indian. So after doing the subset, we will have to run this code down. When we run it, it will basically show it here. After doing that, we will have to see whether there's a whether this group is the ethnicity is normal or is not normal. So we have to create a Shapiro's test. Shapiro test to check whether it's normal or not. So basically we have to put group 1 $, ethnicity, group sign, sorry, not ethnicity, we have to put for income because towards their monthly income. So we have to find Shapiro's test on the income. Now it's for the second and the third one as well. Just have to re-amend it. Put for group 2 now instead of group 1, and as well as for group 3. So after doing this, we will basically have to run this code to see whether it's normal or not. So based on the values that I've got in the console, it is shown that the p-value is more than 0.05. So the null hypothesis is accepted in this case, and there is no, and it is basically showing that the ethnicity towards the monthly income, it is normal. So the data is normally distributed. After doing this, we will basically have to, we don't have to carry out the Levene's test for this thing because Mr. Trevor will assume that the variances for these groups are equal. So after doing the Shapiro's test and we basically remove the Levene's test from this, we will basically do the ANOVA test now. So for doing an ANOVA test, we basically have to put result 1. We have to create a vector first. A vector is important to before putting the AOV, because if you put AOV, you'll get a different value. AOV, income, squiggly line, ethnicity, data equals to dataset, then after that we will basically have to put summary, result 1. So after we do that, we'll basically run this code to see whether the AOV is being run. So after carrying out the AOV, we see that the value is 0.21. The p-value is 0.21. So when the p-value is 0.21, we'll have to accept the null hypothesis, and basically we can conclude and interpret from this from my research question that there is no significant difference on the ethnicity towards their monthly income. So to conclude this section, I've basically explained the concepts of an ANOVA test and the differences between a one-way and a two-way ANOVA. After that, I also demonstrated to you on how to conduct a one-way ANOVA on the same data set by showing an example with my own research question. Now I'll move on to part 5 of this assignment. Thank you. This is the fourth part of my assignment, Mr. Trevor. So in this part, I'm basically going to explain the concepts of an ANOVA test and the differences between a one-way ANOVA and a two-way ANOVA. After that, I'll demonstrate to you on how to conduct a one-way ANOVA on the same dataset by using a research question that I've created. So firstly, I'll explain to you what's an ANOVA. An ANOVA is a statistical test that is used to separate observed variance data into different components to use for additional tests. An example of an ANOVA test is, can we find whether there's a significant difference in the mean weight loss among 4 diets. So this is an example of a research question on an ANOVA test. After that, following this, if the variance between the groups is more than the variance within the group, this then show that there is a significant difference between the groups, because the null this is because the null hypothesis will be lesser than 0.05, so we will have to reject it, and this therefore shows that there is a significant difference between the groups. Whereas if the variance between the group is lesser than the variance within the group, this will then show that the null hypothesis will be accepted, and we will then describe that there is no significant difference between the groups. So after stating the what is an ANOVA test, now I'll show you the differences between a one-way ANOVA and a two-way ANOVA. A one-way ANOVA is used to compare the means of usually more than two groups, and is also used when the data is organized into several groups based on a single grouping variable. Whereas a two-way ANOVA is used to compare the effects of two grouping variables on a single response variable. That is the difference between a one-way ANOVA and a two-way ANOVA. So after explaining to you what a one-way ANOVA and a two-way ANOVA is, I will now demonstrate to you on how to conduct a one-way ANOVA on R. So firstly, we'll have to create a research question. So my research question is there a significant difference on the ethnicity towards their monthly income? So that is my research question. After this, we will have to create subsets. Before doing the Shapiro's test. So the subsets are supposed to be written like this: group 1 arrow subset data set comma ethnicity equal sign Malay. Make sure the Malay is in small letter, because if based on the document that is given to me, the table, it is shown that it is in small letters, so we have to follow that. If it's in capital letters, we have to put in capital letters. So now I'll do it for the same thing for group 2, which is for Chinese. Just amend here, group 2 subset dataset ethnicity Chinese this time, so Malay. And now the last one for Indians, group 3 subset dataset ethnicity. Now from Malay we change it to Indian. So after doing the subset, we will have to run this code down. When we run it, it will basically show it here. After doing that, we will have to see whether there's a whether this group is the ethnicity is normal or is not normal. So we have to create a Shapiro's test. Shapiro test to check whether it's normal or not. So basically we have to put group 1 $, ethnicity, group sign, sorry, not ethnicity, we have to put for income, because towards their monthly income. So we have to find Shapiro's test on the income. Now for the second and the third one as well, just have to re-amend it. Put for group 2 now instead of group 1, and as well as for group 3. So after doing this, we will basically have to run this code to see whether it's normal or not. So based on the values that I've got in the console, it is shown that the p-value is more than 0.05. So the null hypothesis is accepted in this case, and there is no, and it is basically showing that the ethnicity towards the monthly income, it is normal. so the data is normally distributed. After doing this, we will basically have to we don't have to carry out the Levene's test for this thing, because Mr. Trevor will assume that the variances for these groups are equal. So after doing the Shapiro's test and we basically remove the Levene's test from this, we will basically do the ANOVA test now. So for doing an ANOVA test, we basically have to put result 1. We have to create a vector first. A vector is important to before putting the AOV, because if you put AOV, you'll get a different value. AOV, AOV, income, squiggly line, ethnicity, data equals to data set, then after that we will basically have to put summary, result 1. So after we do that, we'll basically run this code to see whether the AOV is being run. So after carrying out the AOV, we see that the value is 0.21. The p value is 0.21. So when the p value is 0.21, we'll have to accept the null hypothesis, and basically we can conclude and interpret from this from my research question that there is no significant difference on the ethnicity towards their monthly income. So to conclude this section, I basically explained the concepts of an ANOVA test and the differences between a one-way and a two-way ANOVA. After that, I also demonstrated to you on how to conduct a one-way ANOVA on the same data set by showing an example with my own research question. Now I'll move on to part 5 of this assignment. Thank you. This is the 5th part of my assignment. So in this part, I'll basically explain the concepts of correlation tests and then show you the differences between a Spearman's and a Pearson's correlation test. After that, I'll demonstrate to you on how to conduct a Spearman's correlation test on the same data set by creating my own research question. So firstly, I'll basically state to you what's correlation. Correlation is a term that is used to measure of strength of a linear relationship between the two quantitative variables. There is two types of correlation, which are the positive correlation and a negative correlation. Firstly, I'll talk about the positive correlation. A positive correlation is a relationship between two variables in which both variables move in the same direction. This is when one variable increases, this will then cause the other variable to increase as well, and vice versa. An example of a positive correlation is when you exercise more, this will then cause you to burn more calories. This is one of an example of a positive correlation. So after talking about positive correlation, I'll talk about the negative correlation. A negative correlation is a relationship where one variable increases as the other one decreases. So these are the few types of correlation: a positive correlation and a negative correlation. Now I'll move. Following this, I'll also talk about few types of things that are very important in the correlation test. Firstly, R is really important. The R value plays a vital role in correlation. R refers to the Pearson's correlation coefficient, whereas the R square refers to the coefficient of determination. And I'll tell you few values as well, which is really important. An R value of 0.3 shows that the strength of the correlation is very weak, whereas when the value is between a range of 0.3 to 0.5, this shows the correlation is weak. The strength of the correlation is weak. Next, when the range is between 0.5 to 0.79, it shows the strength of the correlation is moderate. And lastly, when the strength of the correlation is more than 0.8, this shows that it has a strong strength of correlation. So after talking about correlation tests, now I'll tell you the few differences between a Pearson's test and a Spearman's test. A Pearson's test is the first difference between the Pearson's test and a Spearman's test is, for a Pearson's test the variables are continuous data, whereas for a Spearman's test the variables are ordinal data. Next, for a Pearson's test the variables are supposed to be normally distributed, whereas for a Spearman's test the variables do not have to be normally distributed. And lastly, the last difference between the Pearson's test and a Spearman's test is, for a Pearson's test there is a linear association that exists, whereas for a Spearman's test there is a non-linear association that exists. So these are the few differences that I have explained to you from Pearson's test to a Spearman's test. These are the few differences. So now I'll show you my research question for this. So now the next part in this assignment is I'll demonstrate to you how to conduct a Spearman's correlation test on the same data set by coming up with my own research question. So my own research question is there a significant difference is there a significant correlation between the age of the participants towards their scores in a game? So this is my research question. So firstly, we have to do the Shapiro's test to identify whether this data is normal or is not normal. So we have to put Shapiro's test here, data set $, age, Shapiro test, data set $, scores. So I'll run these two codes to see whether it's normally distributed or not. So based on the values that are found in the console, it is shown that the p values are lesser than 0.05. Therefore, this shows that this data is not normally distributed. Therefore, we can use the Spearman's test instead of the Pearson's test. So firstly, we have to call out. So firstly, Mr. Trevor, we have to put question mark core test to see the function of core test. So core test, basically core test, we have to do this. We have to put down this function, data set $h, comma, data set $, scores, comma, exact equals to false, because we have to when exact equals to false, it basically shows there's no ties between here, so that's why we put exact equals to false. And lastly, we have to put method equals to C open bracket hyphen Spearman. So after doing this, we'll just have to run this code, and we'll identify that the R value for this code is negative 0.35136. So when the value is negative, it shows that the correlation the type of correlation is negative, as well as since the value is 0.35, this shows that it is a weak and negative correlation. And since furthermore, since the p value is more than 0.05, we will have to accept the null hypothesis. Therefore, based on this part, there is no significant correlation between the age of the participants towards their score in a game. So basically, to make it easier for you to understand, Mr. Trevor, so basically the age does not affect their scores in the game. So the age does not play a vital role in making sure that those people score higher in the game. For example, a 7-year-old can score even higher than a 9-year-old in this case. So basically, to conclude this section, I've explained the concepts of a correlation test and the differences between Spearman's and Pearson's correlation tests, and I also demonstrated to you on how to conduct a Spearman's correlation test on the same dataset by using the research question that I've created. Now I'll move on to part 6, the next part, to basically explain the next part of the assignment. This is the 6th part of my assignment. So in the 6th part, I'll explain the concepts of a non-parametric test and the differences between a parametric and a non-parametric test. After that, I'll demonstrate to you, Mr. Trevor, on how to conduct a non-parametric test on the same dataset by creating my own research question. So firstly, I would like to state what is the non-parametric test. A non-parametric test are methods of statistical analysis that it does not require a distribution to meet the required assumptions to be analyzed, especially if the data is not normally distributed. Moreover, non-parametric tests also serve an alternative to the parametric tests, such as the ANOVA or the t-test, that can be employed if the underlying data satisfies the certain criteria or an assumption. So this is the concept of a non-parametric test. Moving on, I'll explain the differences between a parametric test and a non-parametric test. So the first difference between a parametric test and a non-parametric test is, for a parametric test, a continuous data only can be used, such as ratio or interval data, whereas for a non-parametric test, all data types can be used, including ordinal and nominal data. Secondly, for a parametric test, only normal distribution can be used, whereas for a non-parametric test, any distribution can be used. Thirdly, a parametric test for a parametric test, the mean is usually the central measure, whereas for a non-parametric test, the median is usually the central measure. Next, for a parametric test, the information about the population is completely known, whereas for a non-parametric test, there is no information about the population that is available. And finally, the last differences between parametric test and a non-parametric test is this: for a parametric test, there's specific assumptions that are made regarding the population, whereas for a non-parametric test, it is an assumption-free test. So these are the few differences between a parametric test and a non-parametric test. So now, moving on, I'll demonstrate to you on how to conduct a non-parametric test on the same dataset by using my own research question. So my own research question is there a significant difference between the reaction time of people after taking the vaccine? So this is my research question. So for a non-parametric test, we will assume that the data is not normally distributed. So we don't have to do a Shapiro's test for this, as the data is not normally distributed. A Shapiro's test is used to see whether data is it normally distributed or is not normally distributed. Whereas for this part of the assignment, since the data is not normally distributed, we don't have to do the Shapiro's test. So we can straight away do the Wilcoxon's test, which is a test that is used to carry out the non-parametric test. So we have to type out Wilcox test right like this, and we have to put dataset $sign time 1 and dataset $sign time 3. So dataset for the time 1 is basically before getting the vaccine, whereas time 3 is after getting the vaccine. So not to forget, we have to put paired equals to true, as this is a paired t-test. Paired equals to true. Exact equals to false. So by doing this, we will then be able, we just have to run the code and see the p-value. Okay, based on the console, it is shown that the p-value is lesser than 0.05. So in this case, we will reject the null hypothesis and basically say there is a significant difference between the reaction time of people after taking the vaccine. So basically, the vaccine, after taking the vaccine, it will basically affect the reaction time of the people. This is all I can show from this part of the assignment. Now moving on to the part 7, where I'll explain the next information. Thank you. This is the 7th part of my assignment. So in this part of the assignment, I'll basically show you Mr. Trevor, on how to produce two graphs from the data set that is given. So let's move on. So for the first thing that we have to do is basically we have to put in the library function ggplot2. The reason we have to do this is, if we don't do this, R won't be able to produce any graph as we haven't installed the package yet. So by typing in library ggplot2, we are basically installing the package. So we'll run this code, and by running this code, as seen in the console, it is shown that the library ggplot2 has been installed. So now we can plot in the graphs that we want to. So the first graph that I'll be plotting in is I'll show you the steps that is needed to plot in the two graphs. The first plot. Now I'll move on to my first graph. For the first graph, ggplot dataset, AES. The reason that we put in dataset is because R will then be able to extract the data from the dataset that is given as shown here. So R will be able to extract the dataset from this table, and then we'll be able to interpret and plot the graph. So AES is basically a mapping system that is used to plot in the function to plot the graphs. AES. So now in AES we have to put in two variables, which are the x variable and the y variable. So for the first graph, I'll put in age as my x variable and score as my y variable. Basically, you can choose any value from this dataset, Mr. Trevor, as your x variable and your y variable. So it is up to you to choose your x and y variable. And for me, I'm choosing age and score for my first graph as the x and y variables. So if we plot this graph, if we plot it now, we will basically get an empty canvas. So we need to add in few more functions to be able to produce a good and a complete graph. So the next thing we have to do is we have to add in geom point and when we add in geom point, we basically have to add in the size of the geom point as well as the color of the geom point. The size of the geom point can be it can be varied to any size that you want, Mr. Trevor. You can put it size 4, size 3, it's up to you. But in my case, I'm putting size 5 for my first graph. And followed by the color equals to hyphen. The color that I want for this graph is blue color. Like I said, Mr. Trevor, it's up to you to put in any color and the size that you want. You can put it size 4, size 3, and the color you can put in green, blue, or red. It is basically totally up to you. So if you put it now, you basically only get in the geom points of the graph, the points that are on the labels of the x and the y axis of the graph. So basically, the geom point is an incomplete version of the ggplot graph. We have to add in another thing that is important to connect those dots together, and those things are the geom line plus geom line, which is really important to connect those dots together. That's the reason why we use geom line. That's the next part of the function that is needed to make this graph complete. So in geom line, basically we have to add in the color of the geom line. Color equals to hyphen. You can put in any color that you want, Mr. Trevor, but in my case, I'm going to put in red color as for my first graph. And this is, now we have to run the code to see what type of graph we're going to get. So when we run the code, we get this type of graph. Wow, it's really fascinating, isn't it? Yeah, Mr. Trevor, this is the first graph that I produced. So basically the blue dots refer to the geom point, and the size of the geom point varies, like what I said to you. You can put it size 4 and the size of the geom point will be smaller. However, if you put a larger size, the size of that geom point will also be larger. And the color of the geom point is blue color. Like I said, you can put the geom point yellow color, green color, or red color. And the dots that are connecting those points are the geom line. And this is the very important reason that you add in the function geom line, is to connect those dots together and make this graph really fascinating, like it's shown in this diagram. So now, after plotting the first graph, I'll show you how to plot another graph. ggplot. We have to add in the same thing again like previously. Dataset, comma AES. Now for the x and y variables, I'll use a different x and y variable. Like I said before, you can choose any x and y variable that you want, and based on the data set shown here. So for now, I'll change my x and y variables to score and time 1. So this is my new x and y variables. Like I said before this, if we plot the graph now, we already get an empty canvas. We have to add in the geom point and the geom line. The geom point is used to basically show that the dots of the graph, whereas the geom line is used to basically connect those dots together and make the graph even better. Geom point the size of the geom point will vary, and it's up to you to put what size. Since just now I put size 5, now I'm going to put size 4. Now I'm going to put in size 4 as the size of the geom point, and the color of the geom point I'll put in a green color now for the color of the geom point. after doing the geom point, we have to basically add the geom line to basically connect those dots together. Geom line now, like as shown here, it's really important to add this line. And now we have to put the color of the geom line. Like I said before, Mr. Trevor, you can put in any color that you want. In my case, I'm going to put in the color as blue. Sorry, we have to put in hyphen first, because R will be able to read it in this case now. See, now this is basically the graph 2 will be a bit different compared to the graph 1. This is because the size of the geom point is different, the color of the geom points are different, as well as the geom line, the colors are different. So now let's observe the changes from and run this code to see what type of graph we produce. This is another graph that I've produced. It looks fascinating again, isn't it? So for this point, basically the green dots refer to the geom point, and the sizes of since compared to the previous graph, the blue color for the geom point for the previous graph was bigger than this. So this shows that there's a difference between when you change the size of the geom points, as well as see for this part, the dots that are in the graph are green color, whereas the geom line, which is basically the thing that connects the dot, the line that connects the dot to each other, is blue color for the graph 2, whereas in graph 1 it is shown the geom line color is red color. So to conclude this part of the assignment, I basically showed you how to produce two graphs from the data set, and also explain the few things that I needed in the graph, as well as why we put in a geom point, a geom line, and etc. Now I'll move on to the next part of the assignment, which is the last part, to explain a few functions that we haven't learned in this semester. Finally, this is the last part of my assignment, and in this part I'm basically going to show you one of the features that I've never learned from this course. So first, one of the things that I never learned is to draw an extremely cool, really cool graph, which is even more better than this. So I'll show you how to draw it, Mr. Trevor. So firstly, we have to call library ggplot 2, right, like this. Library ggplot2, and we have to run this part. Library ggplot2, we run this thing. So now this package is installed like this. Now we put ggplot this one, dataset, es score time 1 at geom line geom point size equals to 4, color equals to green plus geom line color equals to red. We have to add in one more function to make this even cooler. The function is geom smooth. This will basically make the graph even more smoother compared to like this now. Geom smooth here, this app that we never learned in this course, And so in this geom smooth we can basically add a color to make sure that our graph is even better than this one. So the color that I want to add for this one is blue. Blue shown here. So now I'll run this code, and this is the graph that I've gotten based on this based on this new concept that I've learned recently. So basically the gray color parts here, it is basically the standard error, whereas the blue line represents the mean of each of the values, each of the green values. So this is the new thing that I've learned, this is one of the few things that I've learned that is not taught in the syllabus. And basically I want to conclude that these are the few types of statistical analysis that you can do on R, and basically conclude that R is better than SPSS in many ways, such as it being free, such as it being more user friendly, and etc. Thank you for listening to me explaining all this past, Mr. Trevor. Hope you got something from this video. Until then, take care and stay safe.